The rise in demand around the world for highly efficient infrastructures has led to a rapid development in mechanized tunneling technology. As a technology and market leader, Heron Connect offers an entire range of mechanized tunneling technology and puts mobile tunnel factories into operation around the globe. Heron Connect machines work through all geological conditions to create new underground spaces for traffic, as well as supply and disposal systems. Heron Connect offers cost-efficient, environmentally friendly, and safe microtunneling solutions to meet any customer requirements. The universal tunneling machine for all global geological conditions, especially below the groundwater level, is the AVN machine. For tunnel diameters of 2 meters to 4 meters, AVN machines with segmental lining are particularly cost-efficient and economical when laying long stretches of underground pipelines and negotiating tight curves. The series of AVND machines featured here was developed on the basis of existing and proven AVN technology. This machine's pressure chamber means it can switch from slurry to mixed shield mode without interrupting operations. This enables the machine to deal with a wide range of heterogeneous soil conditions. The following animation outlines the advantages of this type of operation. A launch shaft is constructed on the job site. It can be built using sheet pile walls, diaphragm walls, or board piles. The tunnel boring machine is delivered to the job site in modular form. The prefabricated and numbered tunnel segments are stored and sorted at the launch shaft. A separation plant, several sedimentation tanks, and a bentonite mixing plant are installed close to the launch shaft. A grout mixing plant at the surface produces the injection material required to fill the gap between the segments and the surrounding soil. The main crane continuously supplies the machine with segments and auxiliary material. Once the startup procedure and the assembly work in the shaft have been completed, regular operation can begin. To operate the AVN, a closed slurry circuit is necessary. The slurry pump is installed on the backup system, and the feed pump is installed at the separation plant. The system is connected to the tunnel boring machine with slurry lines and hoses. The system is filled with water or bentonite suspension, a mixture of water and clay. Tunneling with segmental lining takes place in 2 alternating steps. These are the actual tunneling operation and the subsequent ring building phase. During the tunneling phase, the AVND machine's hydraulic jacks support themselves against the previously installed ring segment to push the cutter head further into the soil ahead. The force of the thrust jacks is transferred to the rotating cutting wheel, and the cutting tools on the cutting wheel loosen the soil at the tunnel face as the machine moves forward. The cutting wheel is equipped with disc cutters and cutting knives. The type, number, and configuration of these tools depend on the expected geological conditions. Behind the cutting wheel is the crusher chamber. During operation, the entire chamber is flooded with support fluid. The cladded spokes of the cutting wheel act as grinders, working on the principle of a coffee grinder. Large pieces of rock are crushed so they fit through openings in the crusher cone and can be carried away. Together with the support fluid, the excavated soil is suctioned off by the pump and pumped to the launch shaft through the slurry line. Another pump transports the material to the surface, where it enters the separation plant. There, in a process of several stages, the excavated material is separated and removed from the support fluid, and the clean suspension is fed back to the machine. The fluid returns to the excavation chamber through a system of nozzles in the shield. In this way, a closed slurry circuit is created, enabling uninterrupted tunneling. The AVND machine concept allows the machine to switch at any time between three possible modes of operation: slurry mode, mix shield mode, and hard rock mode, and so to adapt to the geological conditions it encounters. When tunneling in homogeneous fine-grained soils, the machine works in slurry mode. In this case, the entire excavation chamber is filled with support fluid. The support fluid, usually water, is piped to the 6 medium-pressure nozzles. The extreme narrowing in the nozzles produces a powerful jet which, in cohesive soils in particular, removes clogging from the cutting wheel and allows high advance rates. Tunnel face support is achieved by creating balance between the natural earth and water pressures and the counterpressure exerted by the support fluid in the excavation chamber. When tunneling through less cohesive, coarse-grained soils, the machine is switched to mix shield mode. Behind the excavation chamber is the pressure chamber, which is empty in slurry mode. In mix shield mode, the chamber is flooded with bentonite and pressurized with a compressed air cushion. To achieve this, the compressed air supply is simply activated, the support fluid enriched with bentonite, and the nozzle configuration switched. Instead of the medium-pressure nozzles, the annulus nozzles are now activated, which feed the bentonite suspension in behind the cone crusher. The annulus nozzles are centered on the suction port and ensure that flow turbulence is kept to a minimum in the excavation chamber. After the communicating pipe is opened, pressure equalization takes place between the tunnel face, the excavation chamber, and the pressure chamber. Any pressure variations at the tunnel face are balanced by the damping effect of the compressible compressed air cushion. The slight overpressure in the pressure chamber set as a default on the compressed air control system ensures that the bentonite suspension can penetrate the tunnel face and form a filter cake. This supports the tunnel face and ensures safe tunneling without settlement or heave. When tunneling in rock formations, the invert nozzle is activated. It flushes away fine particles that settle in the invert area during tunneling. This keeps the annular gap around the machine clear and maintains the overcut. In this case, only the excavation chamber is completely filled with support fluid. The pressure chamber is not in operation. Additionally, support fluid is also supplied via the medium pressure nozzles. After completion of one stroke, the machine operator stops the cutting wheel and puts the slurry circuit into bypass operation. The supply train delivers the segments, grout, and other equipment needed for the next ring lining operation. The segments are picked up by the transfer crane and lowered onto the segment feeder. The transfer crane and the erector use vacuum lifters or a mechanical gripping system to lift the segments. Once the segments have been deposited, the segment feeder transfers them to the erector. The erector positions the segments successively on the previous ring. The hydraulic cylinders are briefly retracted to create space for the next segment. Following installation, the hydraulic cylinders are extended again to hold the segment in position. The installation team bolts the segments to the previously installed ones. The conical key segment completes the tunnel ring. The next stroke can now begin. The segments are fitted with circumferential seals. Once the segments are assembled, a dimensionally stable ring is created, which is fully sealed both circumferentially and against the previously installed ring. The design of the segments and their seals is pressure resistant, so that the high levels of stress exerted by the tunneling forces, water pressure, and soil loads can be safely absorbed. Systematic arrangement of the rings using unequal side lengths of an entire ring allows tunnel routes with tight curves to be achieved. Combined with an electronic water level gauge and a gyroscopic compass, the UNS navigation system ensures the machine stays on course during long and curved tunneling jobs. The navigation software records deviations from the route and displays them to the machine operator in the control cabin. With the aid of the steering cylinders arranged on the tunneling machine articulation and the segment arrangement, the machine operator can influence the direction and follow the predefined route with the tunneling system. Heron Connect AVN machines for segmental lining are suitable for all soil types, for safe tunneling without causing settlement. The use of the AVND machine series with mixed shield mode considerably extends the range of applications for this technology, particularly in heterogeneous soils. With its full-service tunneling, Heron Connect supports rapid construction progress and creates project-specific service packages that include all services required on-site. A global network of subsidiaries, affiliated and associated companies working in related fields allows us to provide advice and comprehensive services around the world, always, everywhere.